So this is the Google Drive. By default, you have uh, collab notebooks created in your drive. In the drive you are using with Google Collab. So by default, you have collab notebooks in there, right? And if you want to, so if you want to like have the data sets in there, you have to like actually upload the data set. So I'm just going to create a new folder, call it sales data, create sales data, and I'm going to upload I'm going to upload the data set in here. It's still uploading the item. It's uploaded now. Um, then you come here, try to mount your drive. So by clicking mount drive, I guess have you are going to have this uh, right. You are going to have this line in your as one of your cells in Google Colab. So you are just going to run the line and you are going to click connect to drive. When you connect to drive, yeah, it's going to ask you uh, to allow access. So you want to be able to select this and continue. Oops, I guess it's because we did not select all the permissions. So let me just simply select all, right, and continue. Yeah. So now your tribe has been mounted. So every time you want to locate your file, you can always see it in here, sales data, right? And you can always copy the path and you know and paste it here. So that is of course after you've imported the necessary libraries. You import pandas as numpy, you import pandas as pd, you import numpy as np, you import cbon as sn, and then you can of course go ahead and make use of pd.readcsv, that is pandas.readcsv, right? uh, and run it and run that. Yeah, so it's as simple as that. So why did we do this? That is because in a situation whereby you are not working with your usual PC, when you are not working with your personal computer, and you need to access the data, right? You would be able to access it if it is in your Google Drive, and you won't be able to access it if it is in your local computer because you switched laptops, obviously. So this is a way of mounting your drive to ensure that you always have access to your data set, irrespective of the device you are using. So then you have df.head, right, to show the first uh, 5 columns, which is going to be starting from 0, and you have d types. So when you are working with data, there are like some processes that are called EDA, exploratory data analysis. So exploratory data analysis is a way of saying um, what is the size of the data that I am given, how do I access it, and what do I make use, what do I make of this data. It's a way of just trying to check the shape and characteristics of your data before proceeding with your analysis. And one of the steps included is df.dtypes, that is checking all the data types, right? Checking all the data types, each column, right? Row ID, order date, ship date, ship name, customer ID, customer name. So what do you observe over here? You see that row ID is integer 64, which is expected anyways. 1, 2, 3, and so on and so forth. Order ID is an object. Order ID can, right, is an object. It's not pure numeric. Ship date, however, order date is an object, which is not supposed to be. So it is ship date. It's not supposed to be. It's meant to be in date variable. It's meant to be.
Um, this is the call recorded.
Yes.
Okay.
Yeah, it's recorded. So date variable, it's meant to be a date variable, right? have object, especially for this two, right? And you have ship mode, which is object also. It can be string, right? But then leaving it as object is not going to change anything. Customer ID is also object, and you have sales, which is plus 64. That is, it contains them decimals, and quantity, which are like whole numbers, which are integer 64. So they are basically whole numbers. Discount is also float, that is contains it contains decimals, right? And so on and so forth. So this is taking us back to data types, list, tuple, one dictionary. Before we move further, do you know the function of this? You know the function of this button?
Which button?
This this button in the middle.
The Gemini?
Yeah. Have you tried it before?
No.
Yeah, it's actually an AI assistant. You can basically upload your data set and you know ask it to analyze for you. And it's going to generate all the codes and run all the cells one line after the other and analyze everything. So that's the Gemini assistant for you. It's really interesting. Maybe if time permits us today, we can try it out. But it's really an interesting tool. So this is list. I think these are like three identical data types. We have list, we have tuple, we have dictionary. So list. So the difference between list and dictionary is that list is capable of taking in variants of these things, capable of taking in various data types, right? List, tuple, dictionary, list, tuple, dictionary is capable of taking in various data types, and you have tuple, which can only take a single data type, right? Tuple, right? Equals tuple are characterized with normal brackets. Lists are characterized with square bracket. So you have um, tuple to be, let's say, class is awful. So tuple are usually normal brackets, carbohydrate. down part. Yeah. So it is not possible to have a tuple like this and now put another data type in here. Oh, or that is a new discovery. Then um, I think tuples are not, they are not mutable. Yeah. So tuple update does not support item assignment. Whereas lists are mutable, can say list index an item 0, 1, 2, 3, 3 equals equal to girl. So you can change an item in the tuple. So let's print list now. So this has changed to girl. It used to be D, now it's now girl because we indexed it, so refer to a particular item on the list and say, oh, let it be this. So that's like the immutability feature, right? And you have this, right, which is, of course, non mutable, right? So when I try to like say 0, 1, 2, 3, at this pattern or in place of pattern or it should be 5. It's rejecting it because it's simply non mutable, right? Those are like the two differences. Those are like the differences between the list and the tuple. I guess we've like discussed the dictionary in detail, right? Dictionaries are usually in key value pairs. Yeah, there's usually a key and a value. So that's by the way. All of these are not supposed to be interrupting with the flow of working with the raw data. So let me just, okay, I'll just cut all of this. Ctrl X, X. So the next thing you want to do is check the shape of the data, right? So you have that the data has 9,994 rows and 21 columns. So all these steps are just, just like a fashion designer giving you a cloth, or you giving a fashion designer a cloth, and they want to go through some steps of, measuring the clothes, telling you how soft the fabric is and all of those. So before you even like start analyzing data at all, you have to do some data dimension checks and some, you know, some data quality checks. So you can also check, I think we've already checked the data types. So another thing you can also do is the descriptive statistics, right? Checking the descriptive statistics. Descriptive statistics, right? Which is usually, df dot what dot describe. Df is the data frame, right? You can as well name your data anything, right? You can. This is the point where we name the data set. At the point of ingestion, right? At the point of ingestion, that's when we name the df. You can name it sales data, right? Whatever you want. Just make sure that whatever you name it is consistent or true. You can name it sales data, you can name it sales, you can name it data, right? You can name it any variable. Just don't name it a reserved name. That a name that is, reserved as one of the functions. That's a reserved name. Right? Let's say you go and name it some for an instance. Oh, am I, am I getting, am I getting wrong with all of these things? Anyways, but it doesn't make sense to name your data some, but just use, you can name it any name. So, and I think I'll also want to go like give some checklists of what to, look out for when you are doing your data, um, when you are doing your initial data checks. So first of all, let me just put this inside. Let me put this inside a text. Right, so you have this, you have so first of all you want to check through the first 5 rows, data head, I think that's no matter what you are working on, even if you are working on a data science project, you always want to check the data head, which is usually the first five rows. Then you want to check for data types. You want to check for data types. You want to check for you want to check for duplicate checks for duplicate. You also want to check for outliers. Outliers can skew the result of your analysis. You also want to check for validity, stuff like validity, consistency. Can you recall the data quality measures? Losing at.
Yeah.
I said, can you recall the data quality measures?
Can I record what?
The data quality measures. Can you recall, like, let's say record, I said recall, like, can you remember the data quality measures that we talked about, I guess, during the.
I don't know. You. I don't know. I can't hear what you're saying. Oh God.
Can you hear me now?
Yes.
I said, can you recall the data quality measures, those measures that we introduced during the beginning of the class? I mean, during the first few
Like
classes.
consistency.
Yeah,
Oh, you already wrote consistency.
you have validity, consistency, you have uniqueness. But uniqueness is simply more like checking for duplicates, right? You have uniqueness, you have
Yeah.
um,
So I cannot remember.
cannot remember. You have currency, just to ensure that the data are current, right? You have which other ones do you have? Are you asking AI? Are you asking AI?
No, I'm not. I'm trying to remember, but it seems like you've written everything. I don't know. Will it be the same thing as what AI is going to give?
Validity, consistency, uniqueness, currency. One, two, three, four. I think there's another one. I guess these are like the major things you check for when you are. Sometimes you want to check for distribution of the data, right? Before now, moving on with your analysis. Let's go. So we are going to be taking this one after the other and see how we can carry them out in Python. So you've already checked, oh, excuse me, you've already checked for your data head and data types. Um, you already checked for the data dimension. You already checked for the types of the data. You already checked for the describe. You already checked for the descriptive statistics. Right. Which is usually, these are 1, 2, 3, 4, 5, 6, 7, 8. They are majorly like 5 point summary, the count, the the mean, the standard deviation, the minimum, the maximum, the 25%, the 50%, the 75%. Just like what you use in analytics tool pack in Microsoft Excel that you check the descriptive statistics. So those data summary are what we refer to as descriptive statistics, and you can achieve that by using the df.describe function. Then, okay, I guess this is going on to look at those quantities greater than 10. So another thing you can also do is this. So let's do that. So the next thing you want to do is check for duplicates. So this is used for commenting, right? Checks for duplicate. This is used for commenting. That's going to be df dot duplicated. So as you can see, there are no duplicates. As you can see, there are no duplicates. So you go to settings, right? Go to settings, and you can change the theme, light or dark. Then go to AI assistance and consent to use generative AI features and continue. And I think with that, you should be able to use AI features. Like, say you want to plot create a box plot. That's going to be DF. The AI assistant should come up. SNS.boxplot. DF, then the particular column you want to access the outlier for. You can only access outlier for numerical variables anyways. That should work. Ah, 1 second, please. So we have different types of. Let us use payment for instance. What's the error all about? Key errors. So there's no payment. Let me simply rerun this. So this is saying the box does not have payments, that it only has sales. So if we look at the list of the columns, anyway, we are going to see that there's actually no payment in the amongst the columns. All we have is sales. So with this, you can see that there are outliers. So all of these tiny circles are outliers. Had it been that you are doing some advanced stuff like, let's say, regression, or you are trying to build an ML model for an instance, had it been you are doing something like that, you would have possibly have to address this. It is an issue that you have outliers in your variable. But due to the fact that you are simply going on with EDA and you just want to do some basic analysis, you can just leave it. So that is how you check for outlier. Then you can also repeat the same step across, you know, all of the numerical variable, or you can write a function that checks for all the outliers at a go. I want to check something. Yeah, I guess that works. So this is the AI assistant I'm talking about. So once you like enable the AI assistance, you can be able to use natural language to suggest your next move, and AI is going to like auto suggest for you. Oh wow, very good. So you can use that self-defined, self-built function to check for the outliers. So this is not complete. So this is the result of the checking for outliers, right? Again, it is important to know how to guard the how to steer the output of an AI to be able to get um, optimal results. So what this did here is to loop through using the for loop to check through all the columns in the data frame and include only numerical columns, right? And it checks for Q1 data frame column dot quantile 0.25, Q3 data frame column quantile 0.75, like here Q3 minus Q1. Then lower bound Q1 minus 1.5 times IQR, which is how you check for outlier anyways. So if anything falls below the minimum item, the minimum value, that means it is an outlier. Or if it falls above the maximum item, it is also an outlier. So that's why most times people prefer to use box plots rather than using this interquartile range. So So this is simply indexing all of the outliers that we have, right? It's simply indexing them that, oh, these are the specific outliers. Outliers in column sales are, 137, these are the IDs for all the outliers. This is not, this is cool, but it's not a way of, visually representing them. So if you want to like visually represent all your outlier, um, use using box plot, display the outliers across the numerical columns. So you can see how outliers affect all the numerical columns, right? It appears that row ID, which had which was supposed to be excluded anyways, row ID, postal code, they are perfect with no outliers. While column sales, on the other hand, the sales column, on the other hand, have a couple of outliers. The quantity also has few outliers. The discounts column also has few outliers. The profit has plenty outliers, both large outliers and small outliers, right? So that's how this works, right? So what's the next thing to check out for? So you can also check for validity, consistency, uniqueness. So uniqueness has been checked for. Um, Validity, apparently, if the data is not valid, how are you going to know? I guess with the data types, you should know that, okay, uh, data is invalid. So another thing you can also check for is consistency and completeness. Currency, that is timeliness, how recent is the data? I think you cannot confirm that with the help of Python. Usually, it's the Python only comes in the downstream side of things when the data engineers pass down the you know data that has past data governance test for use for downstream analysis. So how do you check for completeness? So you check for completeness, checks for completeness, checks for missing value. Still the same thing. You, the f dot is null dot sum. That is to sum up all the null values, right? These are the basic data quality checks that you carry out before going on with your analysis. So as you can see, there is no column containing missing values. There's no column containing missing values, right? And also, screenshot that one. We also want to check for uniqueness. So you cannot check for uniqueness unless it is a categorical column. So if it was to be a numerical column, that is very very granular, and the what's it called now? And the cardinality is very high, right? If it is a numerical column, you have different tons of variant of numbers. But if it is a categorical column, you can of course know that oh, these are the set of categories that we have. So how do you do that? You can use. Let's start with checks for what are we checking for this time around? Uniqueness, consistency. So that's going to be DF. Whatever the case is, um, what's one of the this thing? Okay, there's no payment and it keeps suggesting payments as part of the columns. Let's say country dot unique. So you can see that all the countries are United States, all true. checks for uniqueness. I'll put that named here. You can also check for the unique product names, right? Let's do this. Checks for uniqueness of all the categorical columns. So this is it. So categorical columns. So it used a for loop. Categorical columns are going to be the f dot select types, which include objects, right? Dot columns. For column in categorical columns, so this has already defined what categorical columns are, which are all objects. Uh, but then when you look through the data types, you would realize that some are not supposed to be objects that are claiming to be objects. There are some columns that are claiming to be objects that are not objects. Right? Example is the order dates. Right? If you look closely enough, look at this order dates, ship dates. All of these are not supposed to be objects. Objects are supposed to be reserved for categorical columns. And that's where the problem of validity comes in. Like, are all the data in the correct data types, or are they camouflaging, or are they, you know, are they in wrong data types, more or less. So if they're in a wrong data type, you have to first of all convert them to proper data types. So let's see how this goes. Trying to check for uniqueness of all the objects columns. So it can be a whole lot. You can see it's it's included it's included items like order ID, excluding, you can exclude them, excluding order ID. You have to exclude other dates too. Other date is not a categorical column. Ship data as well. Ship mode, customer ID. So just bunch of stuff. Then customer name. Customer name is a categorical column, but it is too granular. We don't want to see the classes and customer names and everybody's name. Yeah. Segment, country, city. City is a categorical column. States, region. We don't want to see product ID as well. I think the best way must have been to like specify what to include rather than what to exclude, because at this point there are so many that ought to be excluded than what have to be included. Then you have, I guess that's all. Yeah, I think this list is more sane. It is more lean and more sane, right? So if I want to exclude city, we can also put that here. So that's it. And validity, we're going to be circling back to validity later. The bulk of validity is just trying to make sure that all the data are the correct data types, right? That's what validity is. And yeah, so now applying conditional statement. So after like going through all these steps, after going through all these checks for data head, checks for data types, checks for duplicates, checks for outliers, checks for validity, consistency, uniqueness, currency, completeness, accuracy. After all these checks, then you might start checking for distribution. So distribution checks is also, you see, distribution checks and outlier checks are, you know, they are steps that you take in. They are like preliminary steps you take for a more bigger analysis. Usually for a bigger analysis, which include, you know, building a regression model or building some other machine learning model, right? Why? Because these models have assumptions. They have assumptions, and you know the distribution of the model or containing an outlier can float that assumption and can render it invalid. So that's why we check for outliers and distribution of the data. So the next thing you want to do is to also check for applying a conditional statement, right, to filter the data frame. So this is how you filter a data frame. But before we go, let's check the data once again. The f dot head, the f dot head. You have all this. You have all this. The f dot head, and it is important to know that all of these are, you know, it is important to know that all of these are. You can reference all of these, all of these columns. You can reference them, referencing columns, just like you are referencing, just like you are referencing a cell. You can reference with the name of with the name of with the name of the column, right? Just like that, right? You can reference with the name of the region, just like that. So this is just to simplify the code further and tell and explain that you can always reference a particular slice of the whole table using using one of the column headers. So this is how you apply conditional statement to filter the data frame, right? And this is simply you referencing the quantity column and saying that you are only dealing with quantities that are greater than 10. So you can also make some value counts. So value counts just helps who, just like a frequency table, right? Which one has higher frequency, which one has lower frequency, right?
So that's how value counts.
Um,
We have TF client type dot value count. Retail is this, right? Key error. I guess you can check the ship mode. I think this is actually where we move on to the next thing. So like I said, or like you must have noticed, analysis begins with questions, not answers, right? After examining your data and getting to understand it better, you want to actually start asking some questions regarding you know how is the data, right? So regarding what insight are you trying to exactly generate from the data? And I'm going to be citing them here. So let me write it in a text. Insights to be derived from the data. Just have to like 1 second. Wait, do you have any questions so far? I guess you've been silent.
I'm actually just trying to take it all in, so it's more of like I'm just observing it.
What's your like favorite analytical tool? Is it Excel, Python, Power BI, or SQL? Would I have a video to send over for SQL? Which one is your?
What did you say?
I said I remember that I have a video to send over for ERD for SQL. I'm just